The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Problem 15 states a block of mass 2 kilograms is stationary on a horizontal table. The coefficient of static friction between the block and the table is 0.7. What is the friction force in the block? So we have a block, mass 2 kilograms, and it is on a horizontal table. And they gave us coefficient of static friction. And they gave that to you to trick you. Now, forces on this block include a normal force and a force of gravity. Those are the only forces acting on this block. Gravity pulls it in the table, normal force pushes it up. There are no horizontal forces applied to the block. Gravity does not have a horizontal component on the block because it's not on a ramp. So nothing is trying to get this block to move. Now, if you just have a block sitting still, there's no frictional force acting on it. If you tried to push it, then yeah, there would be a frictional force, and it would be equal to basically the force you were pushing with it until you reach to whatever that maximum is. We love giving you static friction questions because you don't do it for a long time, and it's a very tricky concept, and then you don't really ever touch it again. Just remember that if you take μs and multiply it by your normal force, that's the maximum value of friction that friction can have before it starts moving. Okay? Pretty much in this class, you're never going to use this in a force equation because it's never going to be the maximum value. You're going to apply a force, and then friction is going to push back with the exact same amount up until you reach this maximum value. Once you reach the maximum value and actually get a little bit above the maximum value, then it starts moving, and friction is always equal to the kinetic coefficient of friction times the normal force. But you're pretty much never going to use this equation in anything. Okay? So, if there's no force applied to this block on a horizontal surface, then there's no friction pushing it back. If there was friction, and friction alone, then it would be accelerating backwards, and friction can't cause an acceleration. So, like I said, they gave this coefficient to trick you. This is a conceptual question, and many people would even call it a trick question. So, the answer, friction, must be equal to 0. There's no other option in this situation. Final answer.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.